Arjun is a student. He is hungry and goes to the canteen to buy his favorite food, a samosa. The first samosa gives him a lot of satisfaction because he is hungry. The second also gives him satisfaction, but slightly less. By the third or fourth samosa, he is almost full, so another samosa gives him very little additional satisfaction. Eventually, an extra samosa may actually give him a stomachache, resulting in negative satisfaction. Can we measure Arjun's satisfaction? With cardinal measurement, we assume that satisfaction can be expressed numerically. With ordinal measurement, Arjun doesn't assign numerical values to his satisfaction. Instead, he simply ranks his choices. Arjun say satisfaction got by consuming samosa plus cold drink is greater than satisfaction got by consuming 2 samosas, which is in turn greater than satisfaction got by consuming 2 cold drinks. In this chapter, we will concentrate on cardinal measurement. Let us look at a table to understand marginal utility, MU, and total utility, TU, in Arjun's case. Note after first samosa, MU equals TU equals 12 utils. After second samosa, MU equals 8 utils. TU equals 12 plus 8 equals 20 utils. After third samosa, MU equals 4 utils, whereas TU equals 20 plus 4 equals 24 utils. After fourth samosa, MU equals 0 utils. TU equals 24 plus 0 equals 24 utils. Maximum TU reached. After fifth samosa, MU equals minus 4 utils. TU equals 24 minus 4 equals 20 utils. MU is negative and TU starts decreasing. Let us first define the marginal utility of money, or MUM. Marginal utility of money is the satisfaction utils got by spending 1 unit of money. For Arjun, let us assume that the marginal utility of money is 0.4 utils per rupee. For the first samosa, the marginal utility is 12 utils, and the price is 20 rupees. Therefore, MUX divided by PX is 12 divided by 20, which is 0.6 utils per rupee. Since 0.6 is greater than Arjun's marginal utility of money of 0.4, he buys another samosa. For the second samosa, the marginal utility is 8 utils. 8 divided by 20 gives 0.4 utils per rupee. This is equal to Arjun's marginal utility of money. Therefore, Arjun has reached consumer equilibrium. If he were to buy a third samosa, its marginal utility would be only 4 utils. 4 divided by 20 gives 0.2 utils per rupee, which is less than his marginal utility of money. Therefore, he would not buy the third samosa. So, consumer equilibrium is reached when MUX divided by PX is equal to the marginal utility of money. Let us revise the concepts. Utility is the want-satisfying power of a commodity. Let us look at the measurement of utility. Cardinal measurement of utility refers to the measurement of utility in numerical units, such as 2, 4, 6, and 8 utils. Ordinal measurement of utility refers to ranking utility by comparing satisfaction as higher, lower, or equal across different situations. Total utility, or TU, is the sum total of utilities derived from the consumption of different units of a commodity. Total utility is equal to the sum of marginal utilities. Marginal utility, or MU, is the additional utility obtained when one more unit of a commodity is consumed. Let us look at the relationship between total utility and marginal utility. Marginal utility of the nth unit is equal to total utility of the nth unit minus total utility of the previous unit. When marginal utility is positive but diminishing, total utility increases at a diminishing rate. When marginal utility is 0, total utility is maximum. When marginal utility is negative, total utility starts diminishing. The law of diminishing. Marginal utility states that marginal utility tends to diminish as more and more standard units of a commodity are continuously consumed by a consumer. Now, let us look at consumer's equilibrium. Consumer's equilibrium refers to a situation in which a consumer gets maximum satisfaction by spending his given income on different goods and services. Let us look at the assumptions of consumer's equilibrium. 1. The consumer behaves rationally and aims to maximize satisfaction. 2. Utility can be expressed in cardinal numbers, such as 1, 2, 3, and so on. 3. Utility derived from a commodity is not affected by the consumption of other goods. 4. Marginal utility of money remains constant. Finally, let us look at equilibrium in the case of one commodity, say commodity X. Consumer equilibrium is reached when marginal utility of commodity X divided by the price of commodity X is equal to the marginal utility of money. Now, let us look at consumer equilibrium in the case of two commodities, say commodity X and commodity Y. Consumer equilibrium is reached when the marginal utility per rupee spent is equal for both commodities and is also equal to the marginal utility of money. In other words, marginal utility of X divided by the price of X should be equal to marginal utility of Y divided by the price of Y, and should also be equal to the marginal utility of money. This means that the consumer should get the same satisfaction per rupee from both commodities. Now, let us look at the conditions for consumer equilibrium. First, satisfaction per rupee should be the same for all goods purchased and should be equal to the marginal utility of money. Second, the marginal utility of money should remain constant. Third, the law of diminishing marginal utility should hold. Finally, let us look at the principal limitation of utility analysis. Utility analysis assumes that utility can be measured in cardinal numbers, such as 1, 2, and 3. However, satisfaction cannot actually be measured precisely in numerical terms.